section 3.3, angles of polygons. So we have another lot of definitions in this, but it shouldn't be too terribly bad. Polygon, basically, is a closed plane figure made of 3 or more sides, such as squares, rectangle, parallelograms, things of that nature. These are my polygons. These right here are not a polygon, so a circle is not a polygon. This shape right here is not a polygon because it kind of crosses over. Notice that this is all in one spot. This has kind of got like 2 separate planes, not a polygon. And because this has a curve, it's not a straight line, it's not a polygon. All right, there's different types of polygons. We can kind of put them in different categories, but for now, we'll keep it really simple on this one. There's regular polygons, and these are ones that you are usually used to seeing. This where all sides are equal and all interior angles are equal. Some examples would be like a yield sign. It's a perfect equilateral triangle. This would be where all sides are the same. Then you've got your typical octagon, which would be your stop sign that you would see. This is a regular polygon. All sides are equal. And then you got your square. That is a regular polygon. All sides are equal and all interior angles are equal. So these are like regular polygons. Non-regular polygons would be a triangle like this where at least one side is different, or I have this type of weird shape. They're still polygons, but none of the sides, none of the angles are equivalent to one another. Lastly, we have a couple of little terms that kind of go along with it. It's what we call convex polygons and concave polygons. Convex polygons are when all diagonals are inside the polygon. So let me show you what I mean by diagonals. If I were to draw a line from this vertex to this vertex, that's what we would call a diagonal. And I'm going to do it kind of light. That's inside the polygon. If I were to do one here, from this one to this one, it is also inside the polygon, okay? And then I can do the same thing with this one. These two are diagonals inside the polygon. These two are diagonals basically inside the polygon, all right? Now let's look at this last one. If I were to try to connect these two with a diagonal, they are outside of the polygon. So this is what's going on. A convex, all diagonals are on the inside. A concave, a diagonal, at least one is on the outside. This is what I like to look at. If you have a polygon and it looks like it's got for lack of a better word, a cave, maybe that was the best word. A cave that just falls inside the shape, that's concave. It's falling inside, all right? So just a couple of terms just to be aware of. Not something I'm really overly concerned about, but just wanted you to know anyway. The one thing I am concerned about is this right here. Sum of interior angles, this equation right here, that I'm circling over and over and over again. This is like your other best friend, y equals mx plus b. It's also very similar to that. You need to know it. So what this is doing is, you know how in the last video I told you that a triangle has 180 degrees, all the interior angles add up to 180? Well, this equation will tell us how many degrees any polygon is actually worth, okay? So let's just go ahead and get some examples into this right now. So it says find the sum of the interior angles. So we're going to literally use this equation. The sum of the interior angles is equal to n minus 2 times 180 degrees. And in our little equation, it says that n is the number of sides. All right, so that's pretty easy. Basically, I look at the shape, count my sides, 1, 2, 3, 4, and plug it into the equation. S is equal to 4 minus 2 times 180. Now that I do that, I can continue to solve it and simplify it. 4 minus 2 gives me 2 times 180. So the sum of the angles for this particular shape, this quadrilateral, is going to be 360 degrees. Nothing too complicated there. So why don't you try number 2 and 3 on your own and find out how many degrees all of these should add up to be. What you should have got was 540 degrees for number 2, and for number 3, 1,800 degrees. All right, now, so why is this a useful thing? Well, that brings us right to question number 4. So here's a situation where I've given you a bunch of measurements and your job is to figure out x. But the problem is you don't know what all these should even add up to be in the first place. All right, so that's where the sum of the interior angles, that equation, comes into play. So let's go ahead and work this out. We have S is equal to n minus 2 times 180. That's our equation. So first off, we need to find out how many sides I have. 1, 2, 3, 4, 5. 5 sides. So I can plug that into my equation. 5 minus 2 times 180. This would give me 3 times 180. And ultimately, the number is going to be 540 degrees. So all of these should add up to 540. But I need to know what x is. So what I can simply do is just get my handy-dandy calculator out and go 540. And I'm going to subtract each and every one of these angles away, and that will leave me with what x is. So 540 minus 135 minus 120 minus 80 minus 135, and I get 70. So x, that measurement, is going to be 70 degrees. Why don't you try number 5 on your own? See how you do. What you should have gotten for number 5 was x was equal to 150. So let me show you how I did that. First off, we needed to find out how much all these angles should add up to. So we're going to use that equation again. This sum of the angles is going to be n minus 2 times 180. So when we plug that in, we're going to get, how many sides do I have? 1, 2, 3, 4, 5, 6. So 6 minus 2 times 180. That's going to give me 4 times 180. And then that's going to give me 4 times 180 is 720. So all of these interior angles should add up to 720 degrees. But now we need to figure out what's going on. So let's get rid of some things. We know that we can start with 720, and we're going to subtract 90 minus this 120 minus that 120 minus the other 90. And that tells me, whoops, that's not right. Let's try that again. It tells me that Mr. Lewis hit a button wrong. 720 minus 120 minus 90 minus 120 minus 90, and it hits me 300. So that means that this x and this x are both worth 300. So I know that since they're both the same thing, I can divide that number by 2 and I get 150. So can we prove this to be true? Let's do it. We can say 90 plus, what was it? 150 plus 120 plus 120 plus 50, 150, excuse me, plus the other 90 gives me 720. All right. Number 6 is, and 7 are pretty straightforward. Find the measure of each interior angle of the regular polygon. So what this is saying is, it's not just wanting you to find the total measurement, but it's asking you what is each angle worth. It's asking you for one single angle, this single angle right here. So the first thing that we need to do is we need to figure out how much all the angles are worth. Now, what I'm going to do is I'm going to do the easy one first, because that's what I can do, and I'm going to let you do the harder one. So I'm going to work this out. The interior angles, the sum of the interior angles is equal to 9 minus 2 times 180. All right, so how many sides do I have on this thing? 1, 2, 3, 4, 5, 6, 7, 8. So the side is going to be 8 minus 2 times 180. That's going to be equal to 6 times 180. And that is equal to 6 times 180 is 1,080. So I know that the sum of all of these are 1,080. But that's not what it asked me for. It asked me for the measure of each angle. So how many angles do I have? Well, that's kind of easy to do. We can just do a little count again, and you'll notice something here in just a second. This was an angle here. That's 1, 2, 3, 4, 5, 6, 7, 8. Hey, wait a minute. That's the same amount of sides that I have. That is not a coincidence, by the way. So I know that there is a total of 8 angles here. So I can actually divide this number by 8. And what that's going to do is it's going to tell me the worth of the measurement, of each angle. So each angle is worth 135 degrees. So knowing that, why don't you try number 6 on your own? What you should have got for number 6 is that it was 150 degrees for each angle. So this last question, number 8, it says, in pottery class, you are making a pot that is shaped as a regular hexagon. What is the measure of each angle in the regular hexagon? All right, so what do you know? Well, first off, you should know that a hexagon is a 6-sided shape. All right, that's something you should know by now. All right, so we know that this shape has 6 sides. But there's something that's really interesting here, is the term regular. All right, well, we've mentioned that before. What does regular mean as a regular polygon? We stated that a regular polygon means that all sides and all angles are equal. So that makes our life a little bit easier. So it's very similar to what we did up here. We knew that all of these were regular polygons because it told us and it showed us. So we had to find how much the sum of the angles cannot talk today, and then we divided that by the number of sides or the number of angles to get how much one angle is worth. And we're going to literally do the same thing here. All right, so what do? Same concept. We're going to use that equation, n minus 2 times 180. We're going to plug things in. This is a 6-sided shape, so I put 6 in the place of n. 6 minus 2 is 4. So, and 4 times 180 is going to give me 720. So all the angles add up to 720 degrees. But that's not what it asked me. It asked me what one angle was worth for this regular hexagon. Since we know it's a regular hexagon, we can divide this number evenly by 6. And that tells me that each angle is worth 120 degrees of that regular hexagon. And that's it for this video. This one's, again, I feel like it's pretty straightforward as long as you're using this equation. I will give you a heads up though. Some of the problems that are going to be coming your way, you have to use this equation, but you also are going to have to use some algebra skills that we've seen before and used before. That's not going away. I'm not showing you how to do those in this video because I want you to try them on your own first. See if you can figure it out. But like always, come and give me a holler if you need some help. And I'll see you in the next video. Bye-bye.